Hello friends, in today's question, a particle is moving along a circular path with a constant speed 10 meter per second. What is the magnitude of change in velocity of the particle when it moves through an angle of 60 degree around a center of the circle? So let's draw the, you can say, free body diagram or diagram for the given question. So it is given that we have two particles, only one particle, and it is moving. Suppose this is center O and this is initial position A, and it is moving with a velocity of v1 and it moves an angle of 60 degree. So let us suppose this is angle of 60 degree. This is its final position B, and it will be moving here, let us suppose, with the velocity of v2. So we have to find out the change in the velocity. You can say A is the initial position of the particle with the velocity v1, and B is the position of the particle after an angle of 60 degree having velocity v2. So we are going to find out their magnitude. For that, let us find out the angle between the v1 and v2. Okay. So this is our center O, and we have A, and here velocity will be a tangential v1. It moves through the angle of 60 degree, and now the velocity is v2. So let us draw a line parallel. This is center O, parallel to OA, and extend this one. Okay. So we get this will be 60 degree, and draw the vector, or rather we can say transpose the vector v1 along this point, which is B, and this will be our v1. So we are going to get this angle, because this is entire angle is 90, so this will be coming as 30. Also v2 will be perpendicular to this extension. Okay. So entire angle is 90, so this angle will be coming as 60. So therefore you can say that the angle between v1 and v2 is our 60 degree. So this is our v1 and this is our v2, and this angle is 60 degree. So we have to find out the change in velocity. Change in velocity, that is delta v, which can be given as v1 square plus v2 square plus 2v1 v2 cos of the theta. So change in the velocity, write it here, delta V will be equal to magnitude of V1 minus V1, which can represent this formation. Okay, now let us find out what will be the angle theta. So we already know this is point B. So this is our V2 and this is our V1. So it is V2 minus V1. So let us transpose V1 vector in the opposite side. So now this will be minus of V1. So we have this angle was over 60 and this will be 120. So theta will be equal to 120. Okay. And secondly, we got the value of theta, and V1 will be also equal to V2. You can say, but V1 is equal to V2. Let us suppose that is equal to V. So we can modify this equation as delta V is equal to, this will be twice and twice. So this will be coming as, V will be coming as common. So this will be 2 plus 2 and cos of 120. Cos of 120, V is given as 10, and we have this is 2 plus 2 and this is minus 1 by 2. So this cancels out. We get this equal to 10 square root of 2 minus 1. You can say that change in velocity, that is delta V, will be equal to 10 meter per second. So this is the change in the velocity. This is change in velocity through an angle of 60 degree. Angle of 60 degree. So this completes the question. Thank you.